Hello and welcome. This is going to be our homework help video for the starting value practice quiz. So for all of these questions, we are focusing on the starting value of a linear relationship. So let's take a look at that in the form of a table in problem number 1. Find the starting value of the equation for the two given points. Show your work for full credit. So here's what I want to do. I have to start by finding the rate of change first because I'm going to use that to find the starting value. So to get the rate of change, I draw these arrows on the outside of my table. And on these arrows, I write how much the numbers changed by. To get from -2 to 8, I had to go up 10. To get from 5 to -5, I had to go down 10. I can then use this as my delta y, this is my delta x, plug it into the formula delta y over delta x to get that the rate of change here must be -10 over 10. -10 divided by 10 is -1. So this is just my m value. So I might write m right below it, just to remind myself that that's my m value. Now I can use the m value in combination with one of these 2 points to solve for b. And I'm going to pick the top one here. You could pick the bottom one, or you could test with the bottom one after you've solved it. So I know that when x is equal to -2, y is equal to 5. Therefore, I can fill in my equation y equals mx plus b with a -2 for the x and a 5 for the y, and then take this -1 and fill it in right here for the m. So I'm filling in 3 of the 4 things in this equation, and that's going to enable me to solve for the fourth thing, which is what we really want. All right, so I put a 5 in for y, -1 in for m, a -2 in for x, and you say plus b. And now we just solve this up. -1 times -2 is a +2. To get b by itself, I'm going to have to subtract 2 from both sides. 3 equals b. We can circle that. We are done with this problem. We have found the starting value. Another way to think about the starting value is what is y equal to when x is equal to 0. This is going to be our y-intercept. All right, let's try this starting with 2 points, like in problem number 2. So very similar to problem number 1, I just want to take these points and put them into a table so I can just use that same technique. 6 across from the 7, 2 across from the 4, and then on the outside draw these arrows showing that to get from 6 to 2, I need to go down 4. To get from 7 to 4, I need to go down 3. Now delta y over delta x becomes -3 over -4, because the top and the bottom are both negative. Those can cancel out, and I'm left with an m of 3/4. Now I can pick either of these points to plug in. I'm going to pick that top one. Now I'm going to pick the bottom one. It's got smaller numbers. Plug it in to y equals mx plus b. So the 4 goes in for the y. The 3/4 goes in for the m. Sorry about that. And the 2 goes in for the x. All right, when I multiply a number to a fraction, I multiply it to the top of that fraction. So this 2 is going to go on top of this 3 and become a 6. So 4 equals 6 over 4 plus b. I'm going to go ahead and simplify that fraction down, make this 4 equals 3 over 2 plus b. I'm dividing the top and the bottom by 2 there. I'm going to subtract 3/2 from both sides. In order to do this, I need to swap that 4 out with something that's equivalent to 4. So at first I make it a 4 over 1, and now I want it to have a common denominator, so I multiply the top and the bottom by 2, I make it 8 over 2 times 2 times 2, minus 3/2 equals b. And then now that the denominators match, it just subtracts the numerators. 8 minus 3 is 5, so I'm just going to leave this as 5 over 2 equals b. Improper fractions are totally fine for starting values. That's what I would rather see. All right, so that's number 2. 3 and 4 are very similar. Let's go look at starting value from an equation. So for number 5, we just have to kind of line this up with y equals mx plus b. I'll write it right above it. Y equals mx plus b. and then just pick the number that's in the position of B. And here it's -4. Don't forget the negative. The negative comes with. For this one, it's 9. And for this one, it's +4. This one's a little bit out of order, but we have to recognize that our starting value is also just the constant in the equation. They put the variable over here to be a little bit tricky, but this 4 is definitely our starting value. All right, let's look at these graphs. Starting value from a graph is pretty easy. We just have to look, where does our line cross the y-axis? This one crosses the y-axis down here at 3. It's 1, 2, 3 units below the origin, so that's definitely a -3. And for this one, I bet you can figure out what the starting value is. It is the value of y right here, right at that green dot. All right, a couple more. Should take you 2 seconds to identify where those are crossing the y-axis. Let's look at this one. A little bit different. A line passing through the point 4, 4 and has a rate of change of 1/2. So very similar, but we're given the rate of change, so we don't have to solve for that like we did in problems 1 and 2. And then we don't have a choice which x and y to borrow. We have to use these ones here. As x and y, this is m. We fill it into y equals mx plus b. And we get that 4 equals 1/2 times 4 plus b. 1/2 of 4 is 2, so 4 equals 2 plus b, minus 2 minus 2, b equals 2. All right, and you can try it again with number 13 there. Let's take a look at Gretchen's work and try to figure out the error she made. Gretchen said the starting value is where the graph starts. This graph starts at -5, so the starting value is -5. The error here is that where the graph starts is not defined as the leftmost edge, so she's somewhat right there, but she doesn't pick the right point. Technically, the graph starts right here, and we think of this section of the graph as being sort of backwards in time, and this section over here to be forwards in time, and this is like the present. So right now at the start, we are actually at 1, 2, 3, 4 above the axis. So 4 is the correct starting value. And I'm going to trust you guys to write up the sentence explaining that error in Gretchen's work. She's picking this point over here. That's our x-axis. We need where it crosses the y-axis. And that's defined to be where it starts. All right. Well, hopefully that's been helpful. Have a good rest of your day.